this before. Now I'm missing you and I'm wishing you would come back through my door. Ooh. Do you just feel the love in the air after this song? That relationship was just so interesting. Well, instead of talking about love relationships today, because you really don't want me to talk about that, we're going to talk about angle relationships. So, angle relationships, 5.2b is I can apply theorems to triangle angles to solve problems. So, we're going to be looking at 4 different angle relationships within triangles and then set up equations with them. All right, the first one is the triangle sum theorem. The triangle sum theorem. And that basically is saying that all the angles in a triangle will add up to 180 degrees. So the sum of the angle measures of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So all triangles, no matter if they're acute, obtuse, right, or equiangular, they're going to equal, all the angles added up together are going to equal 180 degrees. So let's take a look at this example. Let's find the measure of angle C. So first, we can apply the triangle sum theorem and say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And then we can substitute in 35 and 90 for measure of angle A and measure of angle B. Add them up together and get 125 plus the measure of angle C equals 180. Subtract 125 on both sides and we get that the measure of angle C is 55 degrees. So this is how we find like the third angle in a missing in a triangle. So don't worry about the context of this problem because I think the context is quite cuckoo because who finds the angles between people's houses in a store? But just know that these are the expressions of the angles. And so we know that these angles added up are going to equal 180 degrees. So we can say that 2y plus 6 plus 8y plus 10 plus y plus 32 is going to equal 180 degrees. And once we've set it up, it's just like we've done tons of times before. We're going to then solve for y. So we're going to combine like terms and then subtract 48 on both sides and divide by 11. And we'll get that y is equal to 12. Okay? So the key thing here is that the angles of a triangle, the sum of the angles of the triangle, will add up to 180 degrees. So that is triangle sum theorem. All right, that was relationship number 1. Relationship number 2, it starts off with interior and exterior angles. So similar to like when we were doing like 2 lines in a transversal, there was like the interior part and then the exterior. Well, there's interior angles of a triangle. Whoops. Interior angles of a triangle, and then there's exterior angles. An interior angle is formed by 2 sides of the triangle, so it's like all the angles that are inside the triangle. And an exterior angle is formed by 1 side of a triangle and an extension of an adjacent side. So like 1 side of the triangle and then an extension of it. To kind of help you guys out, an interior and exterior angle are always supplementary. They're always a linear pair. So an exterior and its adjacent interior angle are always supplementary. So angle 1, 2, and 3 are interior angles, and angle 4 is an exterior angle. So a remote interior angle is an interior angle that is not adjacent to the exterior angle. So in this case, angle 1 and angle 2 are remote interior angles, and angle 4 is the exterior angle. And so the way that I kind of remember remote, it's kind of like a remote island. It's like far away from civilization. Well, these remote interior angles are far away from the exterior angle, angle 4 in this case. So that brings us to our second theorem for angle relationships, exterior angles theorem. So when I was growing up, I called it remote interior angles theorem. I thought that was just a cooler name, but you can call it either exterior angles theorem or remote interior angles theorem. I will accept both of them. The measure of the exterior angle of a triangle is going to be equal to the sum of the measures of its remote interior angles. So the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. This is because because of triangle sum theorem, these three angles will add up to 180 degrees, and angle 3 and angle 4 are always a linear pair. So they're basically like 1 and 2 are supplementary with angle 3, and angle 4 is supplementary with angle 3. So since they're both supplementary to angle 3, we can then say that they're equal to each other. All right, so let's find the measure of angle G. So angle G and angle F are remote interior angles to the exterior angle GHF. So we can say that the measure of angle F plus the measure of angle G is equal to the measure of angle FHJ. So we can say that 60 plus the measure of angle G is equal to 111 degrees. Subtract 60 on both sides, and we get that the measure of angle G is 51 degrees. All right, the remote interior angles are always equal to its exterior angle. All right, the third relationship deals with the third angles theorem. So if we know that in two triangles, if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. So in this case, we know that angle L and angle R are congruent, and angle M and angle S are congruent. Since we know that these two pairs of triangles these two pairs of angles are congruent, we can say that angle N and angle T are congruent. So angle N is congruent to angle T because of the third angles theorem. So let's find X. We know that angle L is congruent to angle P from the arc marks. We know that angle K is congruent to angle N because of the double arc marks. So by the third angles theorem, angle M must be congruent to angle Q. And if they're congruent to each other, their measures are equal. So we can substitute that in and say 6x plus 10 equals 7x minus 2. 6x plus 10 equals 7x minus 2. So then we just solve for x, and we get that 12 equals x, or that x equals 12. All right? So we used third angles theorem here to say that angle M was congruent to angle Q, saying that their measures were equal, and then we set up that equation, 6x plus 10 equals 7x minus 2. So as you can see, all of these so far, these three, we were setting up equations for them. Now for the last one. Where is the largest angle in relationship to the longest side? So AC looks to be like the longest side, and angle B seems to be the largest angle. Well, it turns out angle B is opposite or across from side AC. So angle B is across from side AC. Now, where is the smallest angle in relationship to the shortest side? Where is the smallest angle in relationship or in relation to the shortest side? Well, AB looks to be like the shortest side, and angle C, seems to be the smallest angle. And so, yeah, angle C is opposite or across from side AB or segment AB. Okay. So angle-side relationships. In essence, the easiest way to remember it is by just doing the conclusion of this part. So the larger angle is opposite the longer side. The larger angle is opposite the longer side. And also, the longer side is opposite the larger angle. Okay? But now I'm going to go into further detail. Okay, so if two sides of a triangle are not congruent, like AB is greater than BC, the length of AB is greater than the length of BC, then the larger angle is opposite the longer side. So since AB is the longest side, the measure of angle C must be larger than the measure of angle A, because the biggest angle is across, sorry, the longest side is across from the biggest angle, largest angle. And then kind of the other way around works as well. If two angles of a triangle are not congruent, then the longer side is opposite the larger angle. In a triangle, the longer side is opposite the larger angle. So here we know that the measure of angle Z is greater than the measure of angle Y. Therefore, XY is going to be greater than XZ. Okay? So we can apply this to ordering our angle measures or our side lengths of a triangle. Okay, so here we have a triangle F, H, and G. So write the angles in order from smallest to largest. Okay, so the shortest side is GH, and opposite GH is angle F. So angle F would be the smallest angle. We don't know what the measure of angle F is. We just know that it's going to be the smallest angle because it's opposite the shortest side. Next is FG. FG is the next shortest side, and it's across from angle H. So it's going to go angle F, then angle H, then angle G. Angle F, angle H, then angle G. So because they're across from ascendingly longer sides. Now let's do the reverse. Write the sides in order from shortest to longest. Okay, so we have a 60-degree angle and a 72-degree angle. First, what we're going to need to do is use the triangle sum theorem, our very first relationship that we looked at, to figure out what is the measure of angle R. All right? So we know that the measure of angle R is 180. All triangles have 180 degrees, minus 60 plus 72. So that equals 48 degrees. So we know that the measure of angle R is 48 degrees. All right. All right. So now what we can do is that since 48 degrees is the smallest angle, the shortest side is going to be across from it. So PQ is the shortest side. Next would be QR because that's the second shortest, smallest angle. And then lastly would be PR because that's the biggest angle. It's across from the biggest angle. So PQ, then QR, and then PR. All right, and that's it. We are done with 5.2. Please go on and take the online quiz. Thanks, guys, and have a good one.